So this video is a continuation of the methods video that I posted earlier, and picking up, I think, where I left off was just that conversation about encouraging students to feel safe in your classroom. So what you want to do is you want to build that atmosphere where it's okay for students to make mistakes, to not be right all the time, because what you're dealing with is you're dealing with anxiety, and anxiety comes from this little part of the brain here called the amygdala. And the amygdala is your fight or flight response. It controls that. So, the difference between, oh my gosh, there's a lion, we gotta run, and you can't have my antelope shank, and I'm gonna hit you over the head with it. Okay. So the problem is our brains don't discern the difference between real threats and perceived threats. And in this modern time that we live in, there are so many perceived threats that a lot of times our amygdala is kind of like engaged almost constantly, depending on who you are and how you process things. So what you need to do is be aware of that. You're going to have students like that in your classroom, not only in general, but in terms of dealing with math. As soon as they walk into that classroom, they may be experiencing anxiety. And so you want to address that from day one. You want to make them as comfortable as possible without, you got to be careful with that whole classroom management discipline thing and dealing with students. But, from an academic perspective, you want to make them as comfortable as possible. Support them, teach them, to kind of calm down, how to focus, those kinds of things. Deep breathing techniques will help. And so if you address your math instruction from that perspective, that students are going to have issues and they're going to have a lot of anxiety issues, then what you're doing then is at least you're setting them up for some success. Even if they don't accomplish the learning goals that you have for that specific moment, any little thing that they do that is showing an adaptive behavior is going to be a success. Okay? So, keeping that in mind then, that's what you want to do. You want to create, excuse me, safety in the classroom. And you do that by having an open environment where mistakes are encouraged. Because you want to make sure that they can at least, feel free to contribute in whatever way that is. Okay. So that was, I think, the final thought that I ended up cutting out on the last video. So what I really wanted to talk today was one significant thing which I've noticed in algebra instruction, which is an absence of thought behind teaching factoring. And anytime you guys go through any other content area, geometry, trig, whatever, if you've got any questions about specific things, let me know. But Algebra 1 is still a place where you can do some hands-on activities and have things make sense. Well, I should say geometry is as well, because it's Euclidean geometry and it happens in a plane, so there's no reason for you not to model a lot of things happening there as well. But with algebra, you can model polynomials with algebraic blocks, and you can get manipulatives for that, but there are lots of things online too. And all you have to do is Google model algebraic equations, and you'll get some virtual things that you can use. Again, going back to that, if you can, start with the abstract or start with the concrete and work your way to the abstract. But if you're at a higher developmental level, then you can, if you have to, at least, kind of come down here to this 2D level first before you go to the abstract. If you're teaching younger students, no. And if you're teaching students who struggle developmentally with basic math concepts, then no. You want to be as concrete as possible. But if you've got what I would call a typical Algebra 1 class of high schoolers where they have reasonable skills, then you should be okay with a technological representation. All right, so in teaching factoring, I kind of follow the method that I was taught, which a lot of people do, but I really feel like this is a good one. This guy was super good at conceptualizing and making things simple. It's funny, I just saw him the other day, my high school algebra teacher. He's close to 80. I had a swarm of bees. He keeps bees, and I had a swarm of bees out here on my fence post, and he came and picked him up, so it was funny. But anyway, with those concepts, the first thing that you want to start with is the easiest, right? So start with the easiest things and work your way down. That would be my suggestion for progression. So common terms, factoring for those. And so an example being, if you've got 4x squared plus 4, teaching students to recognize when there are things that can be pulled out. That may seem simple. It's simple for you guys, but when you're first starting out, it's not quite so simple. And so breaking that down into thoughts of, okay, questions. What do they both have? And then can I divide it out? All right. So in this case, yeah, we can, because, and again, talking about factoring, what you want to do is you want to set this up in a scenario where first you're, remember, setting up prior knowledge. So if you activate their prior knowledge with things like factors of normal numbers, well, what are the factors of 4? Factors of 4 are 4 and 1 and 2 and 2. So factoring polynomials is the same thing. We're still breaking up an item into its products, into its respective pieces, a multiplier and a multiplicand. So when you do polynomials, you're doing the same thing that you would be doing with a regular number. And so when we look at things that they have in common, that's what we can do too. We can see, oh, well, here I've got a 4, then I can divide it out. I'm not going to do that because I know you guys know how. But number 2, then I would go with difference of 2 squares, because you're just adding one more term to the process. And it's not difficult. So you're only looking for the 2 things, and it's easy for them to recognize because they're only looking for 2 terms that are both squares. Now, if they don't know what squares are, that's a problem. You're going to have to hit them over the head with that a lot. Constant repetition until they remember what that is, and then separated by a minus sign. All right. Then you can work your way up to the more complicated processes. So, the perfect square trinomial. Not only that, but just factoring trinomials in general. These two can happen simultaneously, because what you can do is you can just identify the special cases that you have. So in factoring trinomials and teaching them that process, then you can identify what's special about this particular one, and then they can see that this is a pattern that happens every time they have a particular setup of terms. And helping them to discover that would be more powerful than you just telling them. So I would kind of recommend really just encountering factoring trinomials from the beginning, and then having them look for patterns in different trinomials that identify them as perfect squares. They'll remember them better that way if they figured it out themselves. Okay? Always remember that. With math, it's the hardest subject there is to stray away from lecture only. And that was one thing I didn't like about having to do Calc 3 the way we did it this semester, because we had so much difficult information to cover that we had to do it that way. That was the fastest way to get through the content. But it's not the way that is most conducive to learning. You want to You want to lead students to discover as much as you can on their own, because if they can figure it out on their own, they're going to remember it better than if you tell them. So, but this is the piece that I wanted to talk to you about, was the factoring trinomials. So there's a pattern that is exhibited here. And what you want to do is you want to teach them what that pattern is. Unfortunately, all the handouts and things like that I had before were on my old computer, which crashed. So there are different ways to approach this. If I can find it, I'll send it to you guys. But I had some students about a year or so ago who had learned factoring in a different way, and I can't remember what that's called. But I'll look for that and I'll send that to you as well. But the way I was taught was this. So if you've got, let's see if I can come up with something that makes sense. Okay, a trinomial like this. What you've got is, and I'm not sure how you guys learned it, but what I do is I look for factors of 6. Okay, so I look for factors of the constant term, and whatever my coefficient here is for the x. Now here's a 1, so it's irrelevant. I only need to look for factors of 6, but then my signs tell me what I'm doing with them. So I'm looking for factors of 6 that add up to 5. Okay, then this sign tells me what goes where. So if I'm looking for factors of 6 that add up to 5, so I take my x's and I put them here. Again, teaching that what we're doing is reverse FOIL. Okay, so factors of 6 that add up to 5 would be 3 and 2. So I can just throw my 3's and 2's in there. And then the last thing I could do is double check this. Now, what this is saying is, it's saying that this sign is going to go with a certain particular combination, but this tells me what that's going to be. If it's a plus, it means the signs are the same. If the signs are the same and they're both minus. So let's just FOIL real quick to make sure that it works. So x squared minus 2x minus 3x is minus 5x plus 6. So that works. So this does several different things here. Whatever this sign is, it tells us either that we're going to take factors that add up to the middle term, or if it's a minus sign, factors that differ by the middle term. It also tells me how I can put those signs in the parentheses. If this is a plus, the signs are the same, and they're whatever this is. If this is a minus, the signs are different, and I'm going to put whatever this sign is in front of the bigger product. Let's see if I can come up with another one off the top of my head that might work. I'll keep these simple so I don't make too many mistakes. Let's see, let's go differ by. Let's do this one. So x squared minus x minus 12. And so here I've got factors of 12 that differ by 1. My signs are going to be different, and I need to put the negative in front of the bigger product. So let's get started. Factors of 12 that differ by 1. That would be 4 and 3. But what you can do is you can have students write those things out. Okay, so parentheses, and then x's. I know my 4 and my 3 are going to be the ones I want. Now here, this is telling me that when I subtract them, I want my answer to be negative. That means I need to put the negative in front of the bigger number. So right here, that means that one's positive. And so then I can double check real quick. X squared plus 3x minus 4x is minus x minus 12. And that gets it. Okay? So going back then to, and I'm going to show you a little bit more involved way, but going back to this idea of, you know, if you've got something here, then you're just looking for factors of both, that when you put them together, they will form that combination that gives you the middle term. I'm going to show you that in another video along with another method of doing that. I want to keep these videos as short as possible. So, all right. So factoring trinomials, working with this. The key for these is just going to be lots of practice. They need lots of practice in identifying what they are and how they're going to do it.